Imagine a weapon that can fire thousands of rounds per minute, barely making a sound, and powered not by gunpowder, but by the invisible force of magnetism. Now imagine this isn't a sci-fi movie, but a reality being developed right now. This isn't happening in a hidden lab in Silicon Valley or a secret Pentagon bunker. It's happening in China, and the world's militaries are suddenly scrambling to catch up. Just a few weeks ago, China unveiled footage of a weapon that experts once dismissed as pure science fiction, a coilgun, also known as a Gauss rifle, capable of firing at 3,000 rounds per minute. To put this in perspective, that's not just slightly faster than your favorite action movie shootout. It's orders of magnitude beyond what even the most advanced traditional machine guns in the world can achieve. And as this astonishing new electromagnetic gun emerges, the balance of technological power in warfare may be shifting before our eyes. Why does this matter to you? Because the arms race isn't just about soldiers and generals. It's about the future of security, technology, and the very shape of our world. The breakthroughs happening today will ripple out, impacting everything from national defense to global trade, and even the technologies we use as civilians. So what exactly is a coilgun? And why is China's new design causing such a shockwave across military and tech circles worldwide? Let's start with the basics. At its core, a coilgun is a type of electromagnetic weapon. Unlike conventional firearms that rely on chemical explosions to propel bullets, coilguns use a series of electromagnetic coils arranged along a barrel. When a pulse of electricity flows through each coil in rapid sequence, it creates a moving magnetic field, pulling or pushing a projectile at astonishing speed. The technology isn't brand new. In fact, the first operational coilgun was built by Norwegian physicist Christian Birkeland over a century ago. But for most of modern history, coilguns and their close cousins, the railguns, were confined to laboratory experiments and the dreams of military futurists. The dream was simple: a gun that launches projectiles faster, farther, and more accurately, all without the dangerous volatility of explosives. The challenge? Infamously complex engineering. For decades, even the most well-funded laboratories ran into dead ends. Coils would overheat, power supplies would fail, and producing enough electromagnetic force to launch a heavy projectile at meaningful speeds seemed almost impossible outside of the movies. But now, that's changing, fast. Over the last decade, China has aggressively poured resources into electromagnetic weaponry. According to military experts, the People's Liberation Army, or PLA, has made a massive leap with their latest coilgun prototype. Unlike early versions, which depended on massive capacitor banks to release energy in short, powerful bursts, China's new electromagnetic rifle is powered by lithium batteries. This is a game changer. The capacitor-free design is not only lighter and potentially more reliable, it opens the door for practical deployment in the field, not just on ships or static gun platforms. With 3,000 rounds per minute, this coilgun isn't just a technical milestone, it's a potential revolution in how conflicts could be fought. But the numbers are even more jaw-dropping. Chinese military sources claim their next target is a coilgun capable of launching a 124-kilogram projectile, a mass approaching that of a small person, at speeds up to 3,600 kilometers per hour, with a range greater than 100 kilometers. Imagine a weapon that could shoot across a city at hypervelocity, all controlled by software, with no muzzle flash or gunpowder smoke to give away its position. Guan Xiaokun of the Naval University of Engineering summed up the stakes, stating, "Coilguns offer revolutionary breakthroughs in speed, range, power, accuracy, safety, flexibility, and reliability. These aren't the words of a marketer, they're the rallying cry of a new arms race." Let's take a quick step back and see how the world got here. For decades, militaries have sought more advanced weapons that combine speed, precision, and cost efficiency. Chemical propulsion, gunpowder and explosives, has always had limits. Every time you fire a gun, you're wearing out the barrel, risking jams and explosions, and ultimately pushing the limits of what's physically possible. Electromagnetic weapons seemed promising. Railguns and coilguns, both moving projectiles by powerful electromagnetic fields, promised more speed and less wear. But railguns, which use two conductive rails to literally arc electricity through a projectile, have faced nearly insurmountable engineering problems. The U.S. Navy famously spent over $500 million trying to deploy railguns, only to abandon the effort as the technical obstacles mounted. Rails would warp, erode, or shatter from the intense forces unleashed at every shot. Railguns are simple but wear quickly. Coilguns are complex but potentially more durable, noted SpaceDoc, a leading defense technology analyst. Enter the Coilgun, with a more sophisticated, if dauntingly complex, architecture. Instead of relying on direct electrical contact with a moving projectile, the Coilgun leverages a series of electromagnetic coils to induce motion. With the right control algorithms and energy management, Coilguns offer a tantalizing mix: speed, stealth, and accuracy, with none of the barrel erosion that doomed railguns. What catapulted China ahead, according to insiders, is an intense focus on addressing the two main bottlenecks: power supply and magnetic saturation. Early Coilguns needed massive capacitors, which made them too heavy and slow to reload. China's leap to lithium batteries, combined with new coil materials and smart power management, is what's allowing their new designs to function rapidly and reliably. But that's not the only trick up their sleeve. Behind the scenes, China's military engineers are working on so-called smart projectiles, bullets that are shielded from electromagnetic interference, equipped with onboard sensors, and capable of transmitting real-time data mid-flight. In other words, Chinese Coilgun rounds could soon adjust their trajectory in real time, reacting to wind, weather, or even countermeasures. The implications are staggering. Not only would such weapons outpace traditional firearms in rate of fire and stealth, but they could also be tailored for different missions, from riot control to anti-aircraft defense to satellite launching. Serious experts are already talking about Coilguns being used to loft satellites into orbit, potentially disrupting the entire $400 billion global space launch industry. And the arms race isn't standing still. China has already fielded the infamous Metal Storm system, a 16-barrel, 35mm array that can fire up to 400,000 rounds per minute. While this is based on conventional technology, Metal Storm's mind-boggling rate of fire underscores the pace and scale of innovation China is willing to pursue. Of course, the world is taking notice. In the United States, defense planners are re-examining their own investments in electromagnetic weaponry. After the collapse of their railgun project, some are warning that the U.S. risks falling irreversibly behind. Christopher McFadden, a technology commentator, claims, "Coilguns can revolutionize warfare with faster, more accurate attacks." The Pentagon is funneling money back into experimental coilgun research, determined not to let China set the global standard. Yet, and here's where it gets personal, the ripple effects go way beyond the battlefield. Every major leap in military technology soon finds its way into civilian life. Think of the internet, GPS, or even microwave ovens, born in defense labs, now part of everyday life. The precision controls, lightweight batteries, and advanced magnetics being pioneered for these Coilguns could eventually change everything from manufacturing to mining, allowing us to move, cut, or launch things with surgical precision and minimal waste. But the journey from lab to battlefield, and from battlefield to city street, is never smooth. Coilguns face a world of challenges, both technical and strategic. One major problem is magnetic saturation, the point where magnetic materials simply can't be pushed any harder, capping the speed at which a projectile can be accelerated. Overcoming this means developing new materials, new coil winding techniques, and smarter software than anything now in the field. And then, there's the vulnerability to electromagnetic pulses, or EMPs. As John Travato from MITRE warns, dangerous scenarios could arise nationwide due to electromagnetic pulses. If a coilgun or its projectiles are exposed to a deliberate or accidental EMP, they could be disabled or even turned against their users. The electronics are delicate, and a single pulse, whether from a weapon or a solar flare, could shut down systems utterly. Another pressing concern is the integration of coilguns into existing weapons infrastructure. Fitting a battery-hungry electromagnetic rifle onto a warship or armored vehicle isn't as simple as plugging in a new gadget. Power management, cooling systems, and electronic control networks must all be redesigned from the ground up. Ma Weiming, a senior Chinese military engineer, cautioned, "Overcoming challenges in large-caliber, high magnetic density coils is crucial. Success is not guaranteed, but the prize is enormous." There's also a huge question around accuracy. While electromagnetic guns can, in theory, be more precise, the real world is messy. Heat, vibrations, and even the Earth's own magnetic field can nudge a projectile off course. Smart projectiles with real-time data feedback are meant to solve this, but for now, they remain in the prototype stage. Strategically, the global balance of power could shift dramatically. If China is able to successfully deploy these coilguns from ships, ground vehicles, and even aircraft, it would gain a tactical and psychological edge in any confrontation. Military analysts say that integration of coil guns into advanced warships like the Type 055 destroyer is already underway, a move that could tip the scales in any naval engagement. The rest of the world faces hard choices: double down and risk more costly failures, or cede the technological lead to China and hope for some future breakthrough to turn the tide. And what about proliferation? As with every high-tech weapon, the risk that blueprints or working models could leak out, falling into the hands of rogue states or non-state actors, looms large. As China races ahead, the next steps will determine not just military supremacy, but the future of high-speed manufacturing, public safety, and even the way we access space. With so much at stake, a burning question remains: can China turn its laboratory triumph into a battlefield reality? Or will the promise of electromagnetic weapons once again fall victim to the pitfalls of physics and geopolitics? And as the world watches, one secretive test at a time, the clock is ticking on the next global tech revolution. With China's announcement and demonstration of its world-leading coil gun, the entire landscape of military technology is shifting. But how will this story play out over the coming years? Let's explore the possible futures, both thrilling and alarming, that lie ahead. First, consider the international military balance. China's successful deployment of a capacitor-free, lithium battery-powered coil gun firing up to 3,000 rounds per minute sends a clear signal to its rivals. The sheer rate of fire and the promise of ultra-precise, near-silent projectiles represent a game-changer for the People's Liberation Army. Just imagine a battlefield where opposing forces are met not by the familiar crack of gunfire, but by a near-silent barrage of supersonic slugs, each capable of smart guidance and real-time adjustment. Military strategists are already warning of the consequences. As one anonymous analyst at the Center for Strategic and International Studies puts it, China's leap into electromagnetic weaponry could spark a technological arms race we haven't seen since the dawn of the nuclear era. The United States and other powers, already reeling from the sudden collapse of their own railgun projects, like the Navy's $500 million effort, now face pressure to revive or reinvent their programs. The fear is simple. If China fully integrates these coil guns into their naval fleets, especially on advanced destroyers like the Type 055, the entire calculus of naval warfare could change in an instant. Picture this: a Chinese destroyer armed with coil guns capable of launching smart projectiles over the horizon with pinpoint accuracy. Incoming missiles, drones, or even hypersonic vehicles could be intercepted with unprecedented speed. Defensive networks become stronger, and offensive capabilities more unpredictable. As Guan Xiaokun of the Naval University of Engineering highlights, coil guns offer revolutionary breakthroughs in speed, range, power, accuracy, safety, flexibility, and reliability. But it's not just China's adversaries who are nervously recalculating. Regional rivals like India, Japan, and South Korea are expected to step up their own research efforts. Even nations with no direct military confrontation with China may feel compelled to invest, if only to keep pace in a world where electromagnetic weapons become the new normal. Of course, the arms race isn't the only future on the table. The civilian implications are vast. Manufacturing lines could harness coil gun technology to accelerate materials at extraordinary speeds, reducing cost and waste. In mining, rocks could be pulverized more efficiently, using less energy and producing fewer emissions. Perhaps most tantalizing is the prospect of launching satellites into orbit with coil gun-based mass drivers, providing a cost-effective, rapid-fire alternative to traditional rockets. Space access could be democratized, but only if the immense challenges of scale, reliability, and safety can be overcome. Still, many hurdles remain. The specter of magnetic saturation limits how fast a projectile can truly go. Physics, it seems, still has the final word. Integrating coil guns into existing military platforms poses a formidable engineering headache, from power management to heat dissipation. Could hybrid systems, combining the brute force of railguns with the precision of coil guns, offer the best path forward? Some researchers think so, hinting at a future where electromagnetic weaponry grows ever more diverse and complex. As the world eyes China's progress, new risks emerge as well. Electromagnetic pulse, EMP weapons, enabled by similar technology, threaten to wipe out not just military sensors but civilian infrastructure, from power grids to hospital equipment. John Travato of MITRE warns, dangerous scenarios could arise nationwide due to electromagnetic pulses. The line between tactical advantage and strategic catastrophe is growing ever thinner. Yet for every threat, there's an opportunity. The development of smart projectiles with onboard sensors opens the door to astonishing new possibilities. Imagine a munition that not only hits its target, but transmits live battlefield data back to commanders, transforming warfare into something far more connected and unpredictable. In the civilian realm, smart coilgun launch tools could inspect and repair hazardous environments where humans dare not go. And what about the ethical dimension? As with drones, the advent of more precise, adaptable, and intelligent weapons will spark fierce debate about the nature of warfare itself. Is the world ready for combat that's faster, quieter, and more automated than ever? These are questions policymakers and societies must confront sooner rather than later. But let's step back from the grand stage of world affairs. What does this all mean for you, the viewer? Why should an electromagnetic gun in a Chinese laboratory matter to someone thousands of miles away? First and foremost, it's a lesson in technological disruption. History has shown that the nation which pioneers breakthrough weapons technologies can gain an overwhelming advantage, at least temporarily. Whether it was the British dreadnought, the German V-2 rocket, or the American atomic bomb, the pattern is clear. When new physics meets determined engineering, the rules of the game can change overnight. But there's also a more personal lesson. The Coilgun story is about perseverance in the face of daunting physical and technical challenges. The PLA's scientists didn't just stumble onto their breakthrough. They built on over a century of research, from Norwegian physicist Christian Birkeland's early Coilgun, to foundational work at Sandia National Laboratories, to the integration of modern lithium batteries and advanced control systems. It's a potent reminder. What seems impossible today may be routine tomorrow, if enough minds work together on the problem. For professionals in engineering, science, and technology, China's Coilgun saga is a wake-up call. The boundaries of what's possible are moving fast. Are you keeping up? Are you ready to adapt as new tools and new threats emerge? And for all of us, it's a prompt to think critically about the technologies shaping our world. Coilguns promise both opportunity and danger. More efficient industries, quieter cities, or more unpredictable wars and new vulnerabilities. Where do we draw the line between innovation and risk? Let's not forget the resilience hidden in failure. The U.S. Navy's abandoned railgun project is often cited as a sign of defeat, but it also laid the groundwork for coilgun advancements. Sometimes the lessons learned from falling short are precisely what's needed to achieve the next great leap. So, returning to the question posed at the start, will China overcome the remaining challenges and usher in a new era of coilgun dominance? Or will the hard limits of physics and the tangle of complex integration slow or even stop this revolution? The answer, at least for now, is both paths remain open, and the next decade will be pivotal. China's scientists are making remarkable progress, especially in overcoming coil design and power management, from the invention of the capacitor-free circuit to the use of EM-shielded projectiles. But the laws of physics still impose brutal constraints, particularly as projectiles approach the threshold of magnetic saturation. Will new materials, smarter control algorithms, or hybrid approaches tip the balance? Only time will tell. One thing is clear: the rest of the world cannot afford complacency. Christopher McFadden of Interesting Engineering says it best: coilguns can revolutionize warfare with faster, more accurate attacks. The race is on, not just to match China's achievements, but to anticipate their next move. Now, as promised, here's a secret fact that even many military analysts overlook. China's new coilgun isn't just about raw firepower. It's a test bed for something much bigger: integrated electromagnetic systems. The technologies perfected in these weapons are likely to appear first in surprising civilian applications, from high-speed transit to energy storage and distribution. In other words, the coilgun breakthrough could reverberate far beyond the battlefield, reshaping your daily life in ways you might never expect. So what can you do? Stay informed, stay curious, dive deeper into the intersecting worlds of physics, engineering, and global affairs. As the future unfolds, those with the clearest understanding of emerging technologies will be best positioned to thrive, whether that's in the lab, the boardroom, or the voting booth. If you found this exploration of China's coilgun revolution compelling, don't forget to like, subscribe, and turn on notifications for more deep dives into the world's most disruptive technologies. Have a question or perspective on electromagnetic weapons? Leave a comment below. We'd love